Dear student, I shall continue the chapter that is transition element. I had discussed the in the previous classes, that is the introduction, and thereafter the variation of the radii of the transition element and ionization energy, then the electrode potential, that is E naught M2 plus oblique M, and after removal of 2 electron, and M2 plus 2M3 plus. And these are the very important properties. That's why I try my best to consider these properties earlier. Now there are some properties are left, so I discuss this property today. As per the time schedule, 3 property I want to cover today. Let us see the transition metals are metallic or non-metallic. Metallic character. There are simple, no question in this. Metallic character. Transition metals all are metallic, and if they are metallic, then it will carry the metallic character. And what are the metallic character? They are sonorous, they are ductile, they are conductors of heat and electricity, they are malleable, like these properties are. And except one, that is the zinc, that is mercury. Mercury is the metal mercury exists in the liquid state. Except that, there is no such exception. So remember, mercury it will have in liquid state. This is the transition metal. Now why they are so called the metallic? Because they form the metallic bond, and that's why it is known that it shows the metallic character. So this is all about the metallic character. Now the second is the melting point and the boiling point. MP and boiling point of the transition metal. Transition elements or metals, and this is very important, right? Suppose we should be very clear. You talk about the metal, then melting point is a matter that we understand कि metal है, ये melt करेगा. That's why we consider the melting point. Why we consider is the boiling point. Although in the book melting point stress is given on the melting point. Melting point that will depend. Suppose this is a metal and solid, it get converted into, that is the metal. This is called enthalpy of atomization. Now this metal, if converted into the liquid, then here is called delta H fusion. And this liquid metal is considered, that is converted into that is the gases, then it is called delta H vaporization. So first we consider the metal, and metal if in solid converted into the liquid, so that the heat required, that is treated as in terms of the melting point. And when it is converted into the liquid, that liquid when heated, that it will converted into the another form, and that's why we consider it as the boiling point. Now, all transition elements or metals they have high melting point and boiling point. They have high melting point and boiling point, right? Why they have high melting point and boiling point? High MP and BP. High MP and BP, right? Now, if you will look at the figure, because I draw the simple figure, this is transition metal, and here this is the melting point. So if you will see there that the graph is like this, and thereafter this is the 3D series. Simply for this is the like this type of graph. Simply like this, and this type of graph. So one thing is to be mind. This is manganese, this is tactunium, and here is rhenium. And here this is the chromium and the molybdenum, and this is the tungsten. So, so we have to discuss these things. Why transition metal have high melting point and boiling point? This is due to strong metallic bond. Strong metallic bond. And this strong metallic bond will depends upon the number of unpaired electron. This is strong metallic. If question asks why transition metal have that is high melting point due to the strong metallic bond or due to high enthalpy of atomization and due to high enthalpy of atomization. Delta HA, this is called enthalpy of atomization. ये दो फैक्टर है नट सबरी में लिखने के लिए, चूंकि वन वर्ड में आंसर पूछे जाते हैं. So we should the strong metallic bond. Now this strong metallic bond formation will depends upon the interparticle bond formation tendency. So how this will happen? This is if we come from scandium 21 and titanium, vanadium, chromium, Mn, then iron, then cobalt, then nickel, and there is nickel, copper, and the zinc. So here the unpaired electron is 3d1, and this is 4s2, and this is similarly here number of unpaired electron is 4s2, 3d, and this is 3d2, 4s2, 3d2, 3d3, and 3d5, 4s1, 3d5, 4s2, 3d6, 4s2, similarly, and here is 3d10, and this is 4s2. So we talk about the every series. This is 3d, this is 4d, and this is 5d. What is the order of the increase of boiling point? This is a melting point. So this melting point of the 5d series is the highest, thereafter 4d, and thereafter 3d. And simultaneously, if we look at the graph of the atomic number and enthalpy of atomization, then we see the similar pattern that the enthalpy of atomization of the 5d series is more, followed by 4d, and the least is 3d. Means 3d, then 4d, then 5d. Graph is like this type. A graph you will see in the book like this. All graphs are means 5d enthalpy of atomization. Any melting point order 5d, 4d, and this is 3d. This is the general order. There are so many exceptions. And this is enthalpy of atomization. This is 5d, and this is 4d, and this is 3d. Like this. So our aim, why the melting point in a particular series first increases, thereafter it decreases. Now we take it as exception. क्यों होता है इसका भी हम लोग एक्सप्लेनेशन करेंगे. फर्स्ट हमारा कॉन्सेप्ट है कि ट्रांजिशन एलिमेंट को या ट्रांजिशन मेटल का मेल्टिंग पॉइंट बॉइलिंग पॉइंट हाई होता है. टू थिंग्स, दैट इज स्ट्रॉन्ग मेटालिक बॉन्ड और दिस इज हाई एंथैल्पी ऑफ एटोमाइजेशन. नाउ अब है कि स्ट्रॉन्ग मेटालिक बॉन्ड ये कैसे बनेगा. द बॉन्ड फॉर्मेशन will depends upon the number of unpaired electron. So if we move from this to that side, here the number of unpaired electron increases, and from here the number of unpaired electron decreases. That's why up to the chromium, now you will say that the manganese have the 5 unpaired electrons, so its melting point should be higher, but there is a deep in the curve. In the case of tactunium, there is a deep in the curve. Here in the case of rhenium, that is deep in the curve. Its melting point is lower. So the metallic bond formation will depends upon the number of unpaired electron. As the number of unpaired electron increases, interparticle bond formation tendency increases. That's why its melting point increases. Means reason is very clear. Number of unpaired electron increases left to right. Number of unpaired electron increases interparticle bond formation tendency increases, so MPPP increases, so melting point increases. This is the number. So in every series, that is chromium, molybdenum and the tungsten will have the highest melting point in each transition series. This is the first concept, why it will increases the highest melting point. Now if we come at the bottom, that is if it is zinc, cadmium and Hg. Now the another aspects, the zinc, cadmium and Hg are called the soft and have low melting point. They are not very hard, they are soft, right? They are soft because the interparticle bond formation is less, because all the d orbitals are completely filled, because d orbitals are completely filled. And no particle bond formation, interparticle bond formation tendency. That's why its melting point is less. It at the each end, why it will decreases? Because all d orbitals are completely filled. This is 3d10 and 4s2. Now the question, why manganese, tectunium and rhenium, MnTc and rhenium have a deep cut, low melting point, and why manganese shows deep in the each series. ये क्यों शो करता है? Because they will show it will depends upon the interparticle bond formation density. That is, d orbital is here d5 electron, but they are stabilized. They are, that is, less delocalized. They are less delocalized, means not available. They are less delocalized, that is less available, less, because they are tightly held with the nucleus, so are less delocalized, that is less available for bond formation. Now that's why this will have the abnormally low melting point in each series. So the question, why transition element have a high melting point and boiling point, and name the element of each series having the high melting point, that is chromium, manganese, molybdenum and tungsten. Manganese, write the name of the element or the metal in the first series, which shows that abnormally low melting point, that is Mn, tectunium and rhenium, these are. And why these electrons are less delocalized, means they are tightly held with the nucleus, so they are less available for bonding. And if they are less available for bonding and melting point entirely depends upon bonding, that's why they will have the less melting, that is melting point, that show the deep in the curve. This is the reason for this one. Now the another is oxidation state. oxidation state. Oxidation state. So oxidation state is very important for the transition element. Why? It shows the variable oxidation state. Shows variable oxidation state. Question: why it shows the variable oxidation state? Why it shows variable oxidation state? Due to participation of NS N minus 1 D and NS electron. Now why only these two takes part in this one? Because of small energy difference, the less energy gap, small energy gap between N minus 1 D and NS electron. So the question asked, this is the first question, why the transition element shows variable oxidation state? That is, concept should be clear. Variable oxidation state is due to the participation of the NS and N minus 1 D electrons, right? Why they will participate only these two? Because the energy gap between the energy, if we see the energy level diagram, then the energy gap between the NS and the N minus D electrons is orbital is very less. That's why these two orbitals electron takes part in bonding, and it will shows the, that is the variable oxidation state. Now we have say how will say the seed. This is another thing. Suppose we take a scandium. Scandium, this is 21, and this is argon, and this is 3D1, and 3D1 3s2. At argon, titanium 22, argon 3D2, and 3s2. This is vanadium 23, argon 3D3, and this is 4s2. Chromium, that is 24, argon 3D5, and 4s1. So that is manganese 25, this is argon, and this is 3D5, 4s2. This is iron 26, argon, this is 35 and 36, 4s2. Now this is cobalt 27, argon 3D7, 4s2, and this is nickel 28, argon 3D8 and 4s2. Now this is copper, this is 29, argon 3D10, 3D8 and 3D9, 3D10, 4s1, and this is zinc, that is Zn. So argon, this is 3D10, and this is 4s1. So the number of unpaired electron that takes part in this is the oxidation state or in the bond formation. So if scandium is written here, that it will show 1 due to the participation of s electron, then we write 2, and if both electrons are 1, that may be write 2, that may be write 3. Why we write? If one s electron will participate, that shows 1. And it is, although it is not a common oxidation state, the common oxidation state I will discuss later on. So this is due to participation of one s electron plus 1 may be possible. This is possible. Which one is common? That is another thing. Why it will show? That is explained by that diagram. 1, 2, 3. Now here, if again due to both has right where 2, then 3, then this is 4. So for titanium, what will be the oxidation state? That we'll discuss later. Fit due to both electron +2, then +2, +3, +4 and +5. Now chromium +1 may also be so, but this is +1 and +2 may be right, but it is not possibility is there due to 2 electrons where +3, +4, +5, +6 means if d orbital we look at here 1, 2, 3, 4 and this is 4s. So this is 1, 2, 3, 4, 5. 1 electron, 1 and 2, this is 3, this is 4, this is 5 and this is 6. The number of unpaired electron is 6, so it will maximum 6. Here +2 and out of the d5, so +3, +4, +5, +6, +7. And for copper, that is +2 and +3 due to these 2 electrons and d6 is there. So d6 1, 2, 3, 4. 1, 2, 3, 4, 5 and 6. So the common is +2 and +3. Although it may show that is 2, 3, 4, 5. This is 2, 3, 4, 5, 6. 4, 5, 6. Because the number of unpaired electron. That's why it will show the oxidation state. Again we write here cobalt. Cobalt is 7. 1, 2, 3, 4, 5. 1, 2, 3. This is 4, 4, 5, 6 and 7. So what is the oxidation state? Due to these 2, right, we have +2 and here is +3 and here is +4 and here is +5, right? And for nickel it is +2 and we write here 8 for nickel. If we write here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 and 8. So it will be +2, +3, +4, +5 and plus 1, 2, 3, 4, 5. This is more. That's why 2, 3, 4, 5. 2, 3 +4 +5. Similarly, for copper +1 and +2. And for zinc there is +2. But the common oxidation state for this is scandium. And for titanium that is +4. Although titanium also shows the +3. For vanadium the oxidation state common that is represented by that circle, that is +5. And the chromium the oxidation state +3 and +6. These are possible, but the compound form in that oxidation state that is 3 and +6. Iron shows that is manganese. The question asked, write the name of the element of the 3D series that shows maximum number of oxidation state, and that maximum number of oxidation state is equal to the group number because it is a 7B. That's why oxidation number is a maximum 7. The common oxidation state that is 2, that is Mn2O3 and 7. This is the maximum oxidation state. And iron, the common one is +2 and +3. And the cobalt, that is +2 and +3. And for nickel, that is +2. And for iron, copper, +1 exists, but +1 is not stable due to the in some solvent. That's why it is get converted to +2. So +1, +2, and zinc always show the oxidation state +2. So if we can say this is the oxidation state possible for the first series of transition element. Similarly, if we talk about the second series which shows the maximum number of oxidation state, that is by maximum number of oxidation state, and here if we take the that is this is iron, that is osmium, right? It will show the oxidation number that is equal to 8, maximum number. Similarly in this. So this is in the 3D series element, and their possibility to show the oxidation state, and this is very clear that why it shows the possible oxidation state due to participation of NS. यदि 1 इलेक्ट्रॉन ले लेगा तो +1, दोनों ले लिया तो +2, इसका या इसका, और अनपेयर्ड इलेक्ट्रॉन होते जाएंगे, वो भागेगा D का +2 ड्यू टू दिस, +1 electron this, again 1, then it is. Like that, it will show the oxidation state, variable oxidation state. The maximum oxidation state, next point is variable oxidation state, and the maximum oxidation state. In every series, you must remember that in the 3D series, that is in 3D series, maximum oxidation state is shown by manganese, right? Similarly, in the 4D series, that is maximum oxidation state is this is the first, this is chromium, this is osmium, this is osmium, osmium, that is 4D series. This is another one is manganese titanium, ruthenium, Ru, and 5D series, that is it shows oxidation state, that is by osmium. And in +2 to +7, and here to +8, this is also the +8. So this one, the maximum oxidation state shows by the element in each series. Now, in the first series, now there are some important points regarding the oxidation state. Oxidation state, that is points regarding oxidation state. Points regarding oxidation state. Right. First transition series shows oxidation state +2 state as the common oxidation state except scandium. Except scandium. Shows +3. And why it shows +3? If you will have the configuration scandium 21, argon, and 3D1, and this is 4s2, so +1, +2, and +3 I have written. Why it is written? So when all the electrons are participating in bond formation, then what will happen? 3D will have the 0 state. And for other, the removal of s electron, there is a nucleus, this is the 3D cell, and this is the 4s. So removal of electron from the s is more stable than that of is more, because it is outer. So its electron is removal is very stable. That's why the common oxidation state for first series is +2. Right? This is first point. Second point, the variability in oxidation state of the transition element is by 1 unit. Always you have seen that is +1, +2, +3, +4, +5, +6, +7. But when we talk about the p block element, they will show the variability that is 2 and 4. Variability in oxidation state of transition element elements is by 1 unit. 1 unit. Why? Because of the participation of Ns and N-1 d electron. यदि एक एक करके भाग लेता है, ऐसा नहीं दोनों साथ ले रहे हैं, due to participation of N-1 and d and Ns electron. But while the variability in oxidation state of p block element is by 2 unit. Suppose we take as Sn2 plus SN4 plus. We don't write is that is SN2, SN3, then SN4. And this is due to the inert pair effect. Now, this is lead 2 plus, and this is and lead 4 plus. So this is the variability in the oxidation state of the transition. This is the second point. Now the third point. The compounds in the lower oxidation state are ionic. Tisra, compounds in transition metal, compounds of transition metal in lower oxidation state, that is treated at +2 and +3 are ionic, while in higher form covalent compound, for covalent bond. As for example, if we talk about the MnO4 minus, so here the oxidation state, if we calculate +7, and they will form a covalent bond with oxygen. That's why this is the covalent relation, right? Third point. And the fourth point, right? Some, that is oxidation state of a transition metal also depends upon the solvent. Oxidation state depends upon nature of solvent. As for example, they may undergo, depending upon the nature of the solvent, they may undergo oxidation and reduction or disproportionation. Let's say copper 2, so it will under water, so will they go to, this is copper 2 plus. And this reaction is called disproportionation reaction. So here question asked, why copper +1 in aqueous solution is not stable? Because it undergo disproportionation. Here +1, here 0, and here 2. What is disproportionation? If the oxidation state of the same element undergo increase and decrease, known as disproportionation. This is self-oxidation reduction reaction. Here decreases, that's why it is reduction. Here increases, that's why it is oxidation. Now, some of the transition element form compound in zero oxidation state. Give the point. Transition element, metal form compound in zero oxidation state. Right? After zero oxidation. Now, what happened? Because you will take the knowledge of this concept in the coordination bonding. Metal carbonyl bond, zero oxidation. As for example, tetracarbonyl nickel CO4. As for example, FeCO5. So these are why this compound will form a metal to ligand bond, and that is sigma bond. And this ligand, this carbonyl CO, have a lone pair of electron. So they will donate in the empty orbital of the metal atom, and it forms a covalent bond. So it forms a pi bond. This is called sigma and pi bond. So sigma and pi bond, and these are called the synergic bond. So here the oxidation state is 0, and here the oxidation state is 0. This is 0 and 0. Oxygen stabilizes higher oxidation state even more than fluorine. This is very important point. This is I write here, oxygen stabilizes is oxygen or stabilizes the higher oxidation state stabilizes the higher oxidation state even more than fluorine. Now this is the, now here is question. Now so the highest fluoride of this MnF4, but the highest oxide of Mn is Mn2O7. Right, this is Mn2O7, and this Mn2O7 is written as Mn, and this is O, it is O, this is O, and this is O, and this one is also O. This is Mn2. So the question is asked, the fluorine is the most electronegative element, and oxygen is not the most electronegative element. But fluorine form MnF4. Why oxygen form Mn2O7? So the question is based on the concept of the oxidation state. So why? Because this is F is the more electronegative element. If we take electronegativity F, and this is electronegativity of oxygen. So oxygen should will form the, fluorine should have formed the maximum oxidation, stabilize the maximum oxidation state, but it does not show, and it is shown by the oxygen. Why? Because this oxygen have a tendency to form multiple bond. This oxygen will have a tendency, इस ऑक्सीजन के साथ टेंडेंसी क्या है, प्रवृत्ति क्या है, ये मल्टीपल बॉन्ड फॉर्म कर सकता है, जबकि फ्लोरीन मल्टीपल बॉन्ड फॉर्म नहीं कर पाते हैं. इसीलिए हाईएस्ट Mn का फ्लोराइड जो होता है MnF4 होता है, जबकि ऑक्साइड्स ये होते हैं. So this is very important topic. So again I repeat this topic, the oxidation state. First question, why the transition element variable oxidation state क्यों शो करता है? तो वेरिएबल क्यों शो करता है? ड्यू टू पार्टिसिपेशन ऑफ Ns and N-1 d इलेक्ट्रॉन. नेक्स्ट क्वेश्चन कि भाई ये दोनों ही क्यों भाग लेता है? क्योंकि उसके 4s और N-1 यानी Ns और N-1 के बीच में एनर्जी डिफरेंस बहुत ही लो है और लेस है, इसीलिए भाग लेते हैं. राइट. और ऑक्सीडेशन स्टेट जब ये बनाया, तो अब किसी भी एलिमेंट का ऑक्सीडेशन स्टेट आपको मैंने दिखाया कि प्रोबेबल कैसे कितने हो सकते हैं. कैसे 7 बनाया, आई हैव शोन इट. कैसे मतलब कि 2 बना, कैसे 4 बना, पॉसिबल है. लेकिन व्हाट आर द that is considered oxidation state or most common oxidation state, that is another thing. And you will remember the highest oxidation state shown similarly in the fourth D and 5D, right? Now in our concept the 3D is very common. Now what are the important points regarding the oxidation state? First क्या लिखा? In the first series scandium only shows +3, except scandium all shows +2. आपको पूछ देगा कि why oxidation state इसका +2 show करता है? Because the removal of electron from S, thereafter d orbital attains the stability. So d orbitals are very close to the nucleus, so it will shows the oxidation state last. Now variability of oxidation state in transition element. ट्रांजिशन एलिमेंट में आपने देखा कि +1 +2 या +2 +3 +4 +5 +6 ऐसे होते हैं. लेकिन पी प्लॉट में क्या होता है? ये 2 से वेरिएबल करता है. क्योंकि यहाँ वेरिएबिलिटी क्यों होता है? ड्यू टू पार्टिसिपेशन ऑफ एनर्जी, दोनों का क्या ऑलमोस्ट सेम है, डिफरेंट. और यहाँ पर 2 जो होता है वह इनर्ट पेयर इफेक्ट के कारण हाईएस्ट ऑक्सीडेशन स्टेट ग्रुप नंबर होंगे. A lower oxidation state is stabilized by inert pair effect. Now, तीसरा पॉइंट हमने कहा, compound in transition metal in lower oxidation state are generally ionic and higher oxidation state में covalent होंगे. जैसे Cr2O7, there are so many compound, oxidation state आप 6 लेंगे, so they will act as the covalent compound. In between these two, there are some compounds are empiric in nature also. So the fourth point, oxidation depends upon the nature of the solvent. यदि
नेचर में, जैसे कॉपर 1 है, दैट इज अनस्टेबल, so it will get go into the oxidation state +2. So this reaction is called, they may undergo oxidation and reduction, and this is called the disproportionation reaction. The question पूछा है, why copper 1 is that is not very stable in aqueous solution? Answer, because it undergo disproportionation. Like similarly, now 4 point कहा कि ऑक्सीजन तो मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट नहीं है, बल्कि फ्लोरीन है। फ्लोरीन को हाईएस्ट बनाना चाहिए, लेकिन फ्लोरीन Mn के साथ में या किसी के MnF4 ही रिपोर्टेड है, Mn2O7 बनाते हैं। क्यों बनाता है? बिकॉज ऑक्सीजन हैव टेंडेंसी टू फॉर्म मल्टीपल बॉन्ड, व्हाइल that is fluorine not form multiple bond. That's why highest fluoride is MnF4, oxide is Mn2O7. This is all about the metallic character, this is all about melting point, boiling point, and this is all about the oxidation state. And I hope that this lecture will help you to answer the question. You must go through the book and the diagram. Okay.